Hey guys, you're going to be learning virtually today as I am home with a sick child. Thankfully, today's lesson is super easy and it's just a continuation of what we did on Friday. Friday, we talked about writing reactions from word equations and basically balancing those reactions from there. You're going to continue practicing that today. But we're going to add one more step to it, and that next step is to identify the type of reaction. Now, there are 5 types of reactions, and types of reactions are just the categories the reactions fit in that we use as chemists to kind of identify what's going on in the reaction. So, starting out, we have 5 types. Those 5 types are synthesis, decomposition, single replacement, double replacement, and combustion. And we're going to be looking at all 5 of those pretty quickly here. Synthesis reaction are exactly what they sound like. So the word synthesize or synthesis means to make. So if we notice this reaction, this is kind of our guideline for what a synthesis reaction looks like. We start with 2, possibly 3 reactants depending on the reaction. The key here is really our products. If we notice our product side, there's only one thing over there. And how do I know there's only one thing over there? There's no plus sign. So remember, the plus sign is used to identify or to separate reactants from other reactants or products from other products. So if we look over here, we've got a plus sign on the reactant side, and because we have 2 reactants, and again, we could have 3, 4, 5, 6, 10 reactants. It doesn't really matter. The key for synthesis is that there's only one product, and that one product is our synthesis product. It's what's being made from the reaction. Notice decomposition is the same thing, but the reverse. We only have one reactant over here, and again, we know that because there's no plus sign. It's then decomposing into multiple products, and again, plus sign to separate that. And these 2 are inverses of each other, which is going to play a role when we start predicting products, because the products of a synthesis reaction will be the reactants of the decomposition reaction. Okay, so that's decomposition, synthesis. Double replacement and single replacement are also very similar to what they sound like. Both of these have to occur in water, by the way, for these reactions to actually happen. And we'll talk more about that when we do predicting products. But the key here is kind of figuring out what's going on. Y is an element, meaning it's by himself. This could be a diatomic. This also could be a metal. Very commonly, they are metal. AX and AY are compounds. So if we look at single replacement, we have a compound plus some type of element by itself, forming a compound plus some type of element. And notice what's happening here. X and Y are trading places. So A is originally bonded with X. Now A is bonded to Y. Now what's actually happening here is whatever type of substance Y is, meaning metal or non-metal, is who he's going to trade out. In this case, we can make the assumption that Y is a non-metal because he's replacing the non-metal or the second element in the compound. If Y was a metal, he would have replaced the A, and we would have ended up with YX plus A. And that's very normal. And again, we'll deal with that more with predicting products. Double replacement, if we notice, has 2 compounds in it, forming 2 compounds. And all that's happening is X and Y, or B and A, however you want to think about it, are trading places. So the 2 non-metals will trade places, or the 2 metals will trade places. Keep in mind, in both of these types of reactions, our charges are staying constant. They're not changing. So if I started out with copper 2, I'm going to end with copper 2 unless it's becoming, in single replacement, unless it's coming by itself. And again, we'll deal with more of that when we're dealing with predicting products. Right now, we're just looking at trying to be able to identify them. And then combustion is some type of hydrocarbon. A hydrocarbon, just so you are aware, is anything that is a hydrogen and a carbon. Okay, whatever that happens to be. It can also have oxygen in it as well, though commonly it is just hydrogen and carbon. When that reacts with oxygen, it produces, and notice this is oxygen elemental here, so diatomic oxygen. When it reacts with oxygen, it's producing carbon dioxide and water, and these are always the same products we get for these types of combustion reactions. Okay, so those are our 5 types. Let's work on identifying them kind of quickly here, and I apologize, Riley is talking to me in the background, so you may hear her a little bit. First type of reaction. What we notice is we have one reactant, and anytime I see one reactant or one product, I automatically am thinking synthesis or decomposition respectively. So because there's only one reactant and it's breaking down into two products, I'm immediately going to assume that this is a decomposition reaction. I'm sorry, this thing is not calibrated. Decomp reaction. Okay. The next reaction, notice I've got carbon and hydrogen chemically bonded together, reacting with oxygen to produce carbon dioxide and water. That automatically makes it a combustion reaction. The next reaction, if we really look at what's happening here, sodium is bonded with bromine, hydrogen is bonded with phosphate. On the new side, on the product side, sodium is now bonded to phosphate and hydrogen is now bonded to bromine. That's going to make this guy a double replacement, and we'll commonly abbreviate that as DR just because it's easier. If we look at the next reaction, I have multiple reactants, but I only have one product. With that being said, that tells me this is a synthesis reaction. For the next reaction, I have iron by himself and sodium bonded to bromine. Then I have iron bonded to bromine and sodium by himself. This is that single replacement reaction. Okay, and we can kind of keep going down from there. We've got three more. Okay, next one we've got another hydrocarbon. So we have carbon bonded to hydrogen, reacted with oxygen to produce carbon dioxide and water. That is a, whoops, too far down. Combustion reaction, still too far down. Sorry, like I said, this thing is not calibrated today. Sorry about that. Combustion. All right, next one, we've got magnesium by himself, iron bonded to oxygen. Then we have iron by himself, magnesium bonded to oxygen. This is going to be, again, a single replacement reaction. Okay. And last but not least, we have calcium chemically bonded to sulfate, magnesium bonded to hydroxide. Calcium then is bonded to hydroxide, and magnesium is then bonded to sulfate. So this is our double replacement reaction. All right, so like I said, very short and sweet. This is actually really pretty easy. It's just looking at patterns and recognizing those patterns in a balanced chemical equation. So what I want you to do, you have two things to work on today. You have the worksheet from Friday, which you should have over the weekend already gone through and written your reactions and balanced them. But I did tell you you would have some time to work on it on Monday. This is your time to work on it on Monday. So I want you to go through, write those reactions. As you're writing them, I want you to identify the type, and I might suggest waiting until after you balance it to identify the type, because again, balancing can kind of tell us if we wrote it wrong or not. If you're having a super hard time balancing one of those reactions, that probably does mean you have it written wrong, so go back and double check it. Then identify the type of reaction that it is. You will have a secondary worksheet that will be due later this week that I want you to work on as well. That's going to be balancing and writing reactions. We cannot get enough practice with this. Tomorrow we will start predicting products, so just keep in mind you have to have a good grasp on these pieces, writing reactions, balancing reactions, and identifying the type to really be comfortable with predicting products. If you have questions, Ms. Piper or Mr. Mora should be able to help you, and then I will be back tomorrow to work with you. Thanks, guys.